Hey guys, this is Professor Snowball here, and what I'm going to be doing today is I'm going to be starting a series of science-related videos, and I'm going to hopefully keep this going for a while. But starting now, I'm going to start off with photosynthesis, and there are two parts of photosynthesis. There's the light-independent reactions, and there's the light-dependent reactions. So I'm going to start off right now with the light-independent reactions. No, light-dependent reactions. My bad. So I'm going to start off now with the light-dependent reactions, and tomorrow or sometime this week, I'm going to be doing the light-independent reactions. Now, the light-dependent reactions, well, what you see on your screen here is, well, the equation for photosynthesis. But see, this is not photosynthesis. This isn't what it actually is. So what I'm going to be going over is this. I'm going to be going over the photosystems. Now, the first thing there's photosystem 1 and photosystem 2. Now, photosystem 2's thing actually happens before photosystem 1, but they found photosystem 1 first, so that's 1, and photosystem 2 is 2, but whatever, science. But, basically, first thing that happens in photosystem 2 is that H2O is broken down to H plus and O. Now, the oxygen is released into the air, and we, breathe it in, and then the H is released into the thylakoid lumen. Thylakoid membrane, thylakoid lumen, thylakoid space. There's so many names for it, but for this, we're just going to call it the thylakoid lumen. Now, next thing that happens is the electron transport chain. Now, an 1H plus is transferred from the stroma, which is outside the thylakoid, to the inner thylakoid, or the thylakoid lumen, using an electron from that was released from the H2O. Now, photosystem 1 takes NADP plus, and picks up 2 electrons and 1 hydrogen ion and converts it into NADPH. Now, the reason it looks so shocky and whatever is because of the fact that it's energy. Now, this energy is going to be used later on for the light-independent reactions, but I will get in that in a later video. So now, the hydrogen ion movement. The difference in hydrogen in H plus provides E. Hold on, never mind. I don't know what I'm talking about. Hold on. Ignore that. Okay, so now we're going to make ATP. So what's happening right now is there's an overcrowding of hydrogen ions in the lumen. So what's going to happen is that some of them are going to force their way out through this little tube over here on the right, and that's going to make ATP synthase. Now what happens is when they force their way out, this little top spins, and it makes that little P that you see there. So what happens is ADP combines with that P to make ATP. So it goes from adenine diphosphate to adenine triphosphate. Now the H's are released back into the stroma. So now NADPH and ATP, these two energy cells, are going to go to the light-independent reactions. And that will be the Calvin cycle. And I have a picture of the Calvin cycle. It should be going up any second now. And that will go up, and they will go over there, and I'm just going to cut that off, and we will get to that later. So I hope you guys enjoyed, and keep watching for my next video. Thanks for watching.